For this lesson, we are going to talk about fraction unit rates. So we've already looked at unit rates, but we are going to add in some problems involving fractions. So some reminders of important terms here. A ratio is a comparison of two or more numbers that indicates their sizes in relation to another. A rate is a ratio comparing quantities of different kinds of units. So cats to dogs, miles to hours, so two different things being compared. And then more specifically, the specific kind of rate, a unit rate, is a rate that describes how much of something there is per 1 unit. So it's always for 1 unit. And then unit price is the same thing as a unit rate, but we're talking about money, right? So it's the cost per that 1 unit. We are always solving for the cost of one item being sold. So the unit that is not cost is going to be 1. If you don't set up a proportion and you're just going to divide, it is important to note that money always has to be on top for a unit price. But if you do a proportion, order doesn't matter. And then last part, this is what we're actually talking about today, is complex fraction, which is a fraction where either the numerator or denominator, or both, is a fraction. So if we look at this example here, we have a fraction within a fraction, kind of. Fraction on top divided by fraction on the bottom. So let's look at an example. Julia rides her bike at a rate of 1/2 mile per 1/9 of an hour. How far does she ride in 1 hour? So I'm looking at the numbers that are given to me. 1/2 mile per 1/9 of an hour. So the units we are comparing are miles and hours. So I'm setting up a blank proportion with miles and hours. Here we've got 1/2 of a mile per 1/9 of an hour. We want to know how far does she ride in 1 hour. So our hours are 1. We are solving for the miles. Now we've got our proportion that we need to solve. Okay. In this, we have the diagonal that has two numbers in here is 1/2 and 1. So we're doing 1/2 times 1, which anything times 1 is just itself. So that equals 1/2. And then we are going to divide by the number in the same diagonal as the variable. So we're going to divide by 1/9. Now we have fractions that we need to solve. So 1/2 divided by 1/9. When we are solving fractions, we need to keep it, switch it, flip it. So I'm keeping the first number, I'm switching the operation, I'm flipping the second number. So keeping it as 1/2, switching it from division to multiplication, flipping it from 1/9 to 9/1. Now I'm just checking my diagonals to see if they can simplify by anything. Neither of those simplify, so I'm just going to multiply across. 1 times 9 is 9. 2 times 1 is 2. And I'm just going to leave my answer as this. 9/2, we were solving for miles. So 9/2 miles. If you want to convert that into a mixed number, you can. Okay, number 2, Leo read 1/10 of his book in 1/4 of an hour. At this rate, how much of his book will he read in an entire hour? So 1/10 of his book in 1/4 of an hour. So we're comparing the book to the hour. So I'm setting up a blank proportion comparing those both. So 1/10 of his book in 1/4 of an hour. At this rate, how much of his book will he read in an entire hour? So in 1 hour. So 1 matches with hours. X is how much of the book. And now we're going to solve the proportion. The diagonal that has two numbers in it is right here. We're doing 1/10 times 1, which is just going to be the same, 1/10. Then we divide by the number in the same diagonal as the variable. So we're going to divide by 1/4. And remembering, when we divide fractions, we are keeping it, switching it, flipping it. So keeping it as 1/10, switching it from division to multiplication, flipping it from 1/4 to 4/1. Then we're going to use our factor chart to check our diagonals again to see if they can simplify. 1 and 1 is already simplified. 10 and 4 can divide by 2. So 10 divided by 2 is 5. 4 divided by 2 is 2. Now I'm going to multiply across. So on the top, so I'm doing 1/5 times 2/1. 1 times 2 is 2. 5 times 1 is 5. So 2/5, and the unit we were solving for was the book. So 2/5 of his book in an hour. Next one. Number 3. Renee needs 1/3 cups of sugar to make her cookie recipe. How much sugar does she need to make the entire recipe? So 1/3 cups of sugar to make 1/4 of her cookie recipe. So we're comparing the cups of sugar to the whole recipe. So I'm setting up a proportion, plugging in 1/3 cups of sugar to make 1/4 of the recipe. How much does she need to make the entire recipe? So the recipe is our whole, our one. We're solving for how much cups of sugar. And we've got our proportion that we can solve. The diagonal that has two numbers in it is right here. So I'm doing 1/3 times 1, which is just 1/3. And we divide by the number in the same diagonal as the variable. So we're dividing by 1/4. When we divide fractions, we keep it, switch it, flip it. So I'm keeping it as 1/3, switching it from division to multiplication, flipping it from 1/4 to 4/1. And then we need to look at our diagonals again to see if anything simplifies. In this, I don't see anything that simplifies, so I'm just gonna multiply across. 1 times 4 is 4, 3 times 1 is 3. And we were solving for cups of sugar. So the whole recipe would take 4/3 cups of sugar. Number 4, Scott can hike 1.5 miles in 2/3 of an hour. How far can he hike in 1 hour? We're comparing miles and hours. So I'm going to set up a blank proportion comparing those two units and plugging in. We have 1.5 miles for 2/3 of an hour. How far can he hike in 1 hour? So 1 goes with hours. We are solving for the miles. Now we've got a proportion that we can solve. The diagonal that has two numbers in it is this one right here. So we're doing 1.5 times 1, which is just 1.5. We divide by the number that's in the same diagonal as the variable. So we're going to divide by 2/3. Here we have an extra step because now we have a mixed number. So before I can actually keep it, switch it, flip it, the first thing I need to do is convert any mixed number into an improper fraction. So 1 and 1/2. You're doing 1 times 2 is 2, plus 1 is 3. So we get 3/2 divided by 2/3. Now I'm going to keep it, switch it, flip it. Keeping my first number as 3/2, switching division to multiplication, flipping it from 2/3 to 3/2. I'm going to double check my diagonals to see if anything simplifies. In this case, nothing does, so I'm just going to multiply across. 3 times 3 is 9. 2 times 2 is 4. and we were solving for miles, so 9/4 miles. Okay, number 5. Leanne is sewing new curtains for her bedroom. She brought 3.5 yards of fabric, and her total cost was $12. What is the cost per yard? So we're comparing yards, and we're talking about cost, so I'm just going to put the dollar sign. We're talking about yards compared to money in my blank proportion. So 3.5 yards for $12. What was the cost per yard? So our yard is 1. The money is what we are solving for. So now we've got a proportion that we can solve. The diagonal that has 2 numbers in it is right here. 12 times 1 is just 12. And we're dividing by the number that's in the same diagonal as the variable, so we're dividing by 3.5. Before I can keep it, switch it, flip it, I need to turn these into improper fractions. 12 as a fraction, we just write over 1. So this is going to become 12 over 1 divided by, turn this into an improper fraction. 3 times 2 is 6, plus 1 is 7 over 2. Now I can keep it, switch it, flip it. Keep it as 12 over 1. Switch it from division to multiplication. Flip it from 7 over 2 to 2 over 7. Then we check our diagonals to see, does anything simplify? In this case, nothing simplifies. I'm just going to multiply across. 12 times 2 is 24. 1 times 7 is 7. So we get 24 over 7, and we were solving for the dollars. I know that doesn't necessarily make sense. We wouldn't really say it that way. We can leave it in fraction form here. We don't need to make it into a decimal right now. And then number 6, a pool is being filled at a rate of 30 1/4 gallons every 2 hours. Express this rate as a unit rate per hour. So we are comparing gallons and hours. So 30 1/4 gallons every 2 hours. We want to know the rate per 1 hour. I have my proportion set up, and we can solve. So I'm multiplying the 2 numbers in the diagonal together. 30 1/4 times 1 is just 30 1/4. And then we are dividing by the number in the same diagonal as the variable, so we're dividing by 2. Before I keep it, switch it, flip it, I am turning this into an improper fraction. 30 times 4, well, 3 times 4 is 12. So 30 times 4 is 120, plus 1 is 121 over 4. Divided by 2 as a fraction is 2 over 1. Now I can keep it, switch it, flip it. Keep it as 121 over 4, switch it from division to multiplication, flip it from 2 over 1 to 1 over 2. Then we would double check our diagonals to see if anything can simplify. In this case, it doesn't, so I'm just going to multiply across. 121 times 1 is 121. 4 times 2 is 8. So 121 over 8, we were solving for gallons.